Alright, so periodic table, as we know, it is the collection of all the elements and arranged in an order of atomic number. So there are many patterns in there, and this chapter is all about those patterns. So let's get started. The diagram shows the arrangement of electrons in 4 elements. Here is the arrangement. Which 2 elements are metals? Now the key word here is understanding what metals do. And metals are the ones that have ability to lose electrons. They're good at that. And why would anything lose electrons? When the number of electrons that are being lost is small and it takes less energy to do that. This one has 1 lost electron, this one has 2 lost electrons, and that makes it really easy to lose these. Compared to this one, element 2 has 5 valence electrons and this one has 5 valence electrons as well. So obviously it will be difficult to lose all 5 compared to gaining 3. Gaining 3 will require less energy. So most likely 2 and 4 are non-metals and 1 and 3 are metals. Element Z has the following properties. It has high melting point, which tells us that the bonding in there is really strong. Its presence can lower the activation energy for a reaction, which means that this is a catalyst. This is what catalysts do. And there is a group of elements in the periodic table that is good at doing that, and that is transition metals. So both of these things tell me that first of all it has high melting point, so the bonding is strong. So transition metals have strong metallic bonding, which means that this will have high melting point and it's also working as a catalyst. So this is the answer. Element X is solid at room temperature. Again, bonding is strong. It needs 1 electron per atom to gain the electronic structure of noble gas. So it's a solid and needs 1 more electron. So it gains an electron, which means that it's more likely to be a non-metal. It is the least reactive element in the group. So this also confirms the idea that down the group non-metals become less reactive. The reason for that is because the atom becomes really big and it's more difficult to gain electrons. It requires more energy to do that, which is why we are expecting a solid non-metal which is below in the group, and also it is in group 7. It's a halogen. So we know iodine and acetylene are both in group 7. They're really below and they're both solids. So that is why our answer is going to be AT, because iodine is not in here. The diagram shows the part of periodic table. You have different elements in there. Which pair of letter represents elements that are in the same period? Again, remember that period means these rows. And these rows tell us the number of electron shells that they have. So you can see that P is in a period of its own. Q, R and S, they're all 3 in the same period. So that's why they are going to go with D. T is in a period of its own. Which row shows the correct number of protons and electrons in the ion of an element in group 2 of periodic table? So you have group 2, so you're looking for something that has protons in group 2. So just look at the proton numbers and match it with the periodic table. This is magnesium, which is in group 2, number 12. 9 is in group 7 and so on. So you can clearly see that B is going to be an answer. Notice that I did not see number of electrons. I didn't have to, because there's only one option that's in group 2 here. Alright, let's do theory questions. Give the name or symbol of element in group 3 and period 4. So just go to the periodic table, and these questions are usually asked in the very first question in paper 2 for O levels and paper 4 for IGCSE is usually a question like this. So this is group 3 and period 4, so that's gallium. So that's our answer here. An element in period 3 that is good conductor of electricity. So again you have period 3. So period 3 is the one with sodium, magnesium, aluminium, silicon and so on. Aluminium is a good option, so we'll go with that. Element in group 7 that is most reactive. So it's a non-metal, and non-metals are most reactive if they are a smaller atom. So fluorine is going to be our answer here. Element in group 5 that is present in a molecule of ammonia. Now you have to memorize the formula of ammonia, which is NH3, and you have nitrogen in there, so that's why our answer is going to be N. Then an element with an atom containing 8 electrons in the last shell. So that could be neon, argon or any of them, but not helium. So I could go with neon. Now remember one thing, you have to pay attention to what the requirement of the question is. If the question says give the name only, then you write the name, you don't write the symbol. If the question says write the symbol, you do that. In this one, they have given us both options, so that's why I meant with symbol. Sometimes they give you a list to select from, and in that case, you have to copy the element symbol exactly the way it's written in the list that is given. Alright, silver is a transition metal with proton number 47. Use the periodic table to state number of occupied electron shells in an atom of silver. Now, here's the thing. You haven't done a configuration for transition metals. In fact, you haven't done configuration for elements beyond calcium. So, how do we do this? We do this by understanding the structure of periodic table. And the periodic table structure tells me, group number tells me number of valence electrons, and the period number tells me how many shells there are. And this question is actually asking us about number of shells. Silver, if you look in the periodic table, is in period 5, so we will say it is 5. Give two physical properties of silver that are only characteristic of transition metals but not of all metals. So you can say that it has high melting point, because not all metals do that. But you can also mention that this gives colorful compound. So gives colorful compound. Similarly, now here's the thing, sometimes examiners do not take this option, because giving colorful compound comes from the electronic structure, which is a chemical property, which is why in a question where they ask you for just giving the physical property as they have in this one, try to avoid that and mention maybe that it has high melting point, it is ductile, it is malleable, because that is something that not all metals do. So this is ductile. State two differences in the physical properties of metals, potassium and iron. So again, you can mention two physical properties, but mention that it's different for both of them. So for example, potassium has low density, but iron has high density. Similarly, potassium has low melting point. You can combine both of them. You can say the potassium has low melting point and low density, but iron has high melting point. State one difference in the chemical properties of potassium and iron. So chemical properties of metals are pretty similar. They all lose electrons, but how many, that varies. So potassium can always lose one electron. That's what it does. But iron can sometimes lose two, sometimes lose three. So you can mention that iron can lose multiple number of electrons. Or you can also mention that instead of writing it like this, you can say that iron gives variable valency. So iron has variable valencies, but potassium has only one. So again, potassium is +1, and I'm not considering potassium in the element state as a separate valency here. Alright, lead is a metal with proton number 82. Use the periodic table to state number of occupied shells. This is similar to the previous one. We'll place it in the periodic table, find it in group period 6. So we'll say it has 6 filled electron shells. Use the periodic table to state number of electron in the outer shell. Again, look in the group number. This is in group 4, so we'll say 4. Copper is a transition metal. Name two transition elements or compounds which are used as catalysts. So this is something that you have to remember. There are few in your syllabus. I'll mention all of them so you have good revision there. So there is nickel, which is used to do hydrogenation to make margarine. So we make it from vegetable oil. There is iron, which is used in the Haber process to make ammonia. There is V2O5, vanadium 5 oxide, which is used in contact process. Contact process is used to make sulfuric acid, but there are multiple steps there. V2O5 is used when we are producing sulfur trioxide. That's where it's used. And then there are rhodium, platinum, palladium. All three are actually used in catalytic converter. Now this last one isn't really required for you to memorize. You just need to know what catalytic converter does. So it's better that you answer for this one because they are asking for industrial product. We will choose these three, but the fourth one I'm still mentioning it so you still remember it, so that you know what is using catalytic converter to convert harmful gases to less harmful gases. Other than acting as catalyst, state two properties which are specific to transition elements. Now they haven't told us that are these physical properties or chemical properties. So you can mention both of them. So you can say that they have colorful compounds, which is basically because they have variable valencies. They have high density, which not all other metals do, and they have high melting point, boiling point, high conduction, all of that comes here. Alright, let's do this one. Predict. Now, whenever you have a word, command word as predict, you have to use the information given to find a value. So density of liquid krypton. So look over here, you have the densities over here, but krypton is missing. So maybe take an average of 1.4 and 3.52. So if you do that, when you add them, you get 4.92, and 4.92 divided by 2 is 2.46. So maybe give an answer that is somewhere there, 2.46, 2.5, 2.44, something like that. Similarly, if you notice over here, the difference is roughly of 20 or 30. Same from here, same from here. So I can say that this will also be a similar difference. So maybe I could say minus 121 or something like that, and that's acceptable. Your answer might differ from an answer of your friend, and that is because this is a prediction and everybody can have their own prediction for their own reasons, but examiner has a range of answers that they'll accept, so don't worry. Describe the arrangement and motion of particles in a gas. So gas is, again, arrangement is there's no fixed arrangement, it is random, if you want to mention that. And same is the motion is completely free and random, so you can mention that. State one use of argon. You need to memorize the uses of first three noble gases. Helium is used in balloons, neon is used in making lights, and argon is used in manufacturing steel and light bulbs. So you can mention any of them. Noble gases are unreactive. Explain why. Because they have complete lost shell. You can mention they already have an octet, but that won't be true for helium. So it's better to mention that they have a complete outer shell or a complete lost shell. Alright. Part of Mendeleev's original periodic table, showing an arrangement of elements according to their similar properties is shown. Mendeleev listed the elements in order of their atomic masses. What determines the order in the modern periodic table? This is something that I mentioned in the beginning of today's video. So what determines the order? That is atomic number. Mendeleev predicted the properties of undiscovered element X. You will find element X in the table above. Okay, study the pattern in which elements are arranged. Deduce to which group in the periodic table element X begins. So let's go over there. So we were looking for things that are in the similar way between boron, aluminum, and then we have that, and the mass should be somewhere between 65 and 75. So if you look over here, between 65 and 75, we have gallium, we have germanium, and we have arsenic. Arsenic is 74.9, which we already have. So we can say it is gallium, and gallium is in group number 3. So we'll say it is gallium, okay, and we'll mention that it is group number 3. So we are not required to give the name of gallium. We just have to mention the group number. So read the question carefully to understand its requirement. Describe two other differences between Mendeleev's original periodic table and the modern periodic table. Notice that in this periodic table, you do not have any, you might have periods like beryllium, boron, carbon, nitrogen, they're all in the same period, but the period is right now, it is vertical. Similarly, this one is vertical, and again, lithium is in the same group as hydrogen these days, but right now that's not the case. Similarly, this is the group number that we have these days. Beryllium and magnesium are both in the same group, but that's not the case here. So first thing that we should mention is that groups are now vertical but horizontal here. Similarly, we know that in the modern periodic table they are arranged based on their atomic number, but that is not something that we should mention here. You might be inclined to, but notice that they are saying two other differences. So that's something we have already discussed. So then you can say that modern periodic table has transition metals. So transition metals, or you can also mention noble gases, or missing from original periodic table. And you might argue that, wait a minute, I already have transition metal in this one, I can see some of them, but then again that is not mentioned as transition metal. They are part of the original groups or periods that Mendeleev had. That's not the case these days. Iron, cobalt and nickel have similar properties. State the name of the block. So that is transition metal block. That's the name. And that brings us to the end of this worksheet. I hope you understand the properties of periodic table, how to read it, how to locate an element, how to determine the structure of an atom from its location in the periodic table, and then the things that we're supposed to remember, the trends that we're supposed to remember at this stage in periodic table. Refer to the notes if you're still looking for some facts that you need to memorize. Take care.